In the last section, we finally finished writing code to model our insurance company. So in this video, I want to do a wrap up on some of the big things that we learned here about Redux. At this point, I don't really expect you to memorize a lot of the intricate details here. I just want you to have an overall idea of how the Redux library worked. So let's get to it. All right, so first things first, we're going to start to really learn this Redux cycle. This Redux cycle that you see right here has all the same boxes inside of it as the diagram that we were looking at just a second ago. So you can now remember from our analogy the purpose of the action creator. That's like a person dropping off a form. The purpose of our action, purpose of dispatch, and so on. So with the Redux cycle, we essentially start off at the very top up here. Anytime that we want to change the state or the data of our application, we are going to call an action creator. Calling an action creator is going to produce an action object. This action object describes exactly how we want to change data inside of our application. That action object gets fed to the dispatch function, which in turn is going to make copies, we can imagine, of the action object and feed those copies to each of our different reducers. In turn, the reducers are going to run, they're going to process those actions or the forms that came in, modify their data, and then eventually return some new data. That data that gets returned gets formed into some new state object. So then we wait until we need to somehow update our state again at some point in the future. So now we have a somewhat reasonable idea of the purpose of each of these steps inside this diagram. I want to give you some more insight about what's going on inside of Redux now. So I'm going to flip back over to my code over here. All right, so the first thing I want to tell you about was the purpose of this combine reducers call. Remember, the different reducers we put together were simple functions. All these different functions need to be somehow wired up together. We wire up all the different reducers together by making use of the combine reducers function. You'll notice that we have different keys on here of accounting, claims history, and policies. Because we used these very specific key names, we ended up with a state object. Remember, that's what's being console logged right here. That's the result of the console log of store.getState. We ended up with properties on our state object equal to those key names. So we can absolutely feed keys into this object right here with names different from our reducer. For example, if I wanted to, I can change this key of accounting to money we have. And now when this example reruns, you'll see that my state object now has a different key for the accounting reducer. It now says money we have is 20. We do not always have to name these reducers exactly after the keys, but usually by convention, we're going to have them be very similar. Just so you know, you can change the keys right there if you ever want to end up with different state property names. So I'm going to change that back to accounting like I had before. Now, the next thing I want you to understand is that each dispatch that we're doing here is essentially running one of these entire cycles. So we're calling an action creator, getting an action, feeding it into dispatch, that runs our reducers, and we get out some each state. So each of the lines of code that you see here for each of these dispatches is a separate execution of that entire cycle. We can print out our state object in total in between each of those dispatches. We don't have to run all the dispatches and then only after that get access to our state object. Likewise, even after we do a get state call like you see right here, we can still continue to modify our state object after that. So if I wanted to, I can move that console log of store.getState to right here after where we created the policy for Alex. And now we'll see that our current state at that point in time has just policy for Alex, and we only have $120 in the bank. We could then move that again to after we create all three policies, and now we'll see that we're back to the $190, and we've got policies for Alex, Jim, and Bob. And then just as we did before, we could remove the console log back down here as well, and we'll see our final state where we only have $20, and we've only got policies for 2 people. So at any point in time along our application, we can take the store object and pull our state out of it and read the current state or the current data for our application. Now, one thing about Redux that is very interesting is that we can only modify this state object or this kind of assembly of all the data through the use of the dispatch function and the action creators and actions that you've now seen. There's no way that we can somehow manually reach into the store and modify the state in there manually. In other words, you are not going to ever write some code that looks like store.state.accounting -100 or something like that. we cannot get direct access to our state property and modify it in some meaningful way. We're only ever going to modify our state by dispatching an action that has been created by an action creator. All right, so I think that at this point in time, we've got a pretty reasonable idea of some of the basics around Redux. Now, you might be thinking at this point, like I had said much earlier in this section, I had said, all right, here's our difficulty curve. So right now we're still kind of up here, where you might be thinking, wow, this seems way more complicated than it needs to be. So let me tell you why everything is set up this way. You see, in a traditional application without Redux, as an app gets bigger and bigger, like more complexity, more lines of code, usually ends up that the code that we write ends up being more and more complex and harder to understand. And this grows non-linearly over time. So as our app gets larger, it usually ends up that as we grow in size, the app gets dramatically more and more complicated. But with Redux, we get into a little bit flatter curve like this right here. The initial complexity of our application certainly starts higher than if we did not use Redux. Notice how on this diagram, I started the initial complexity way down here. So with Redux, we've got some higher initial complexity. But because we can only change our data through the use of action creators, our application is kind of self-documenting. It makes it really clear to other engineers who start working on your project the different ways in which they can modify the data of your application. People can only modify data inside of your app by calling these different action creators. And so if someone walks on to your application and starts working on it on day one, they will look at these action creators and understand, okay, I can create a policy, I can delete a policy, and I can create a claim. That's the only ways I can modify data inside of this application. And so one of the ideas behind Redux is to get a much more stable or steady curve here of complexity as your app starts to grow. Even though it initially starts out a lot more complex, as your app starts to grow, you're going to get this much more stable, much smaller, and much more linear growth in complexity, in theory at least. That's why we make use of Redux, as opposed to just trying to handle things with React by itself. We want to only have a very small set number of ways of modifying our data. All right, so let's take a pause right here. When we come back to the next section, we're going to start working on a React application, and then we'll learn how to integrate Redux into it. So quick break, and I'll see you in just a minute.